Hi everyone, hope everybody is doing well. So today we are going to talk about machine learning model deployments based on Flask and FastAPI. So these two are two different approaches which have been used for ML deployments. Flask has been there for a very long time and FastAPI is a new thing in the town. Now let's get started with a high-level overview of what these two things are. To show a demo of these two things and to talk about these two things, Flask and FastAPI, I have used the same use case that I used in my last video on machine learning model deployments using Azure ML. The use case which I used is also available on Google, not Google, Kaggle. And the use case was about taxi demand prediction. So that means if we provide the location and the time to the model, it would tell us what is the demand percentage for the cabs in that area at that specific point of time. While training that model, we created multiple artifacts which are listed here. The first is encoder, then there is a k-means, then there is an actual model which is used for prediction. All these three artifacts were created in that Kaggle use case during the training time. And now I'm going to deploy this model using Flask and FastAPI. So let's talk about all these files one by one. The first thing that we are going to speak about is Flask, which is the simplest thing out of these two. It has been there for a long time, so I'm not going to spend much time on it because there are multiple videos already on YouTube to talk about it. So Flask is based on WSGI server. So what we do is, it is a Python-based framework, Flask. Now, if a Python-based framework has to connect to a web server, it should connect using something called as WSGI gateway. Now, when we start Flask API, it basically starts in development mode. So let me just restart Flask API to show you the same. Again, in the command, you can see Flask app. That is the name of the file that I have given here. So that is the reason you see Flask-A Flask app. So Flask app is the name of this file. And you can see this warning. It is a development server. Do not use it in the production. Use production WSGI server instead, right? But we are using it only for development and testing purposes, so it should be fine. So we have two routes. One is the development, or one is the base route. On the base route, we are just printing out a message which says it is a default Flask app. The second is the inference route, which is the predict route. In this, we are getting the data, which is latitude, longitude, and the date time. And we are sending out the demand percentage in the return statement. Now, this return statement is also using the score file. Let me open the score file now. This score file is very much similar to the same scoring file which I used in my last video on machine learning model deployment using Azure ML. There are a few changes here and there. For Azure ML deployment, the scoring file would have an init function, and all these three items would be a part of that function. But here we don't need to do that. We can live with these global variables, which are loading the model artifacts, and then the function, which is just doing the inference or the prediction based on the input JSON which we are passing. The file is very much similar to the file that I used in the last video, and the file along with all the code is also available on GitHub. The link I will put in the description as well for reference. Let's come back to Flask. So that was all about the code, and this is the command that I used to start this Flask app, or to start this here in the terminal. Now it gives me a URL where I can test. So it is running on localhost at 5000 port. So what I have done is I will just open it up. So as you can see here, I have these three inputs. One is longitude, latitude, and pickup date time, which is nothing but location and date time. So when I send this on the predict route on 5000, I get the demand percentage as something. So this is coming out from this Flask server. The base route can also be tested the similar way. You can see that this is a Flask app default page. So this is the base route, which you can see here. This is the Flask app default page. So this was about Flask. Now let's move on to FastAPI. So FastAPI is the new thing in the town. This is based on ASGI interface. Now, what is the difference between Flask and FastAPI? FastAPI is not using WSGI. It is using ASGI, which is an asynchronous interface, which is comparatively better than the server which was used before, which is Flask, right? In terms of supporting asynchronous requests inherently within the framework itself. Now let's look at the file. It is more or more similar to the file that we used for Flask. There are a few changes here and there. One is UV code. So I'm importing this library. This is the library that supports ASGI interface, which is getting used here. Apart from that, we do see another file, which is TDP inputs. Now, what is this function TDP inputs coming from? So this is coming from a file called as TDP input. Your FastAPI uses a library. We can use a library called as PyDentic, which will validate the input parameters in the JSON which are passed on for prediction. So I'm passing these three parameters. I'm telling it that they should all be string, and PyDentic would inherently take care of this and would throw any errors if there are any issues with the input JSON object passed on to predict. Now this TDP input I'm importing here, and the function TDP inputs, which is nothing but this, the class I'm importing here. And if you see here, when you run this FastAPI app, the data would come in from the Postman as a JSON object into this. This validation of these three items would happen here, longitude, latitude, and date time. And then we would come to this piece. These print statements are just for debugging. You can remove them. I just pasted them for debugging. There's no need of them. So the data comes here from this class into data variable. And here I'm converting that into dictionary and passing it into score file, which is returning me the demand percentage. This is running on the port 8000. And the command to run this FastAPI server is given below. FastAPI app is the name of the file. App is the name which is given on the top. So if you see here, app is equal to FastAPI. So that is the same thing which is given here. There's a function reload. There's a parameter reload, so that if there are any changes in this file, we don't need to restart it manually. The restart of the server would happen automatically. Now let's test the FastAPI. So all I need to do is change the port number to 8000 with the same inputs, latitude, longitude, and the date time, and we should get the demand percentage. Hopefully, yes, we are able to get the demand percentage. Now, there's another thing which is interesting with respect to FastAPI. This is something that you might have seen in case of Flask as well. In case of Flask, we have a UI called as Swagger. Through Swagger, you can pull in all the details on the UI. Here we have something which is called as docs. So if you, after the port, if you just type in docs, you would come to this kind of an interface, which is similar to the Swagger. Now here you can test the same thing which you tested using the Postman. So let me do the same thing here. So I'm doing the post. I am trying to predict. Now the data would be same as this one. Right, we are passing the longitude, latitude, and date time, and we are expecting that we would get the demand percentage. So this is a quick way to test rather than opening Postman. And we are getting the output as demand percentage, 88%. Now let us go back to the code. Yeah, so I think that's all pretty much, that's pretty much all about these two different ways to deploy Flask and FastAPI. Thank you so much for joining. Have a great day ahead. Bye.